So we're long overdue for a video about units and quantities and measurement. And you guys are, excuse me, in a very unique situation being in our program because you get to kind of play with these quantities in different units, whereas students in traditional science classes will learn one unit. In a traditional tech ed class, you'd be learning a different unit system. And here in our program, you're going to have to know how to go back and forth between the different fields and different unit systems. So what I've written up here is the metric system versus the imperial system. And you might say, well, I don't know either of those that well. I know a little bit about metrics. I don't know what the imperial system is, but you absolutely do, because we are the only country that still uses this for most of our measurements, and the imperial system, has uses things like feet, or the foot, inches, yards, that kind of thing, right? So the system that we are used to, even think about like measuring cup size things. That's all imperial system. We've adopted that from the British. We've kept on to it. The British have moved on to the metric system, and we're the only ones left using this as our standard measurement system. But what we need to do is, I think you understand feet and inches, and you have a context for that. And you use that certainly in using materials. So in the tech ed classroom, you are using feet and inches for your measurements, and you might be using that as your measurement system in Inventor. But you should know that in Inventor, you can switch to metrics. And so we're going to cover a little bit of metrics. We're also going to talk a little bit about, let me make a list here for you. So what we're going to talk about is the metric system itself, what it's based on, some of the prefixes, things that you need to know. We're also going to talk about scientific notation. All right, and just kind of introduce this idea to you that we will be using over and over and over, especially now that we're going to be doing far more calculations in science. So the first thing is, the metric system. So what you should know is that the metric system is based on, the number 10, right? So all unit conversions are based on this number, which is really convenient because if you've learned any tricks, and I hate to say the word tricks, but of multiplying and dividing by 10, all you're doing is adding zeros or essentially you're moving the decimal place either right or left. If you move the decimal place to the right, you're adding zeros to the end of your number. And if you are moving your decimal place to the left, you're adding decimal places. So we're going to do a little bit of that and then talk a little bit about how this relates to scientific notation. But there are 7 units or base quantities that you need to be familiar with, and you need to start memorizing and becoming familiar with. So we talked a little bit about these today in class, in our last class. So the first one is length. So I'm going to make a little chart here. So this is the base quantity. So we call it a base quantity. And then we're going to talk about the name of the unit, and then the symbol, right? So we abbreviate those. And so the problem is, though, sometimes if we abbreviate and we're not familiar enough and understand what we're doing, if we're just plugging and chugging, the symbol is actually going to kind of mess you up a little bit. So sometimes, especially at the beginning, if metrics are new to you or you're prone to make mistakes, which, let's be honest, we all are, let's write the symbol out. So that's going to be our expectation for now, is to actually write the full name and not the symbol out. So, so for length, the name of our standard base quantity unit, you might already know, is meter, and we abbreviate that with the letter M. All right, that should be pretty standard. For the base quantity of mass, you might say, oh, the base unit's gram, but you'd be wrong. Our base unit for metrics is actually the kilogram. All right, the kilogram, which is abbreviated kg, kilogram. We'll come back to that in just a second. Or base quantity of time. We've already had a discussion about this, but we haven't really talked about it in terms of metrics. Is seconds. So when you guys were doing your photosynthesis labs, some of you wanted to write minutes and seconds, but seconds are our key unit here, and we abbreviate that with S. All right. We haven't gotten this far yet. When we talk, I'm going to go ahead and give it to you though. When we talk about electric current, what we're talking about is the unit ampere, A-M-P-E-R-E, and we abbreviate that with the letter A. Then there's temperature, which you might know, right off the top of your head, you might know 2 units, Fahrenheit and Celsius. But we don't use either of those. We use Kelvin, and we abbreviate that with a capital letter K. There's no degree sign, it's just Kelvin, okay? When we talk about the amount of stuff, of matter in something, we talk about the unit mole. All right? You might not have ever heard of that before, but we abbreviate that. You say it's short enough, it's already 4 letters. Well, we make it 3, right? So MOL is the abbreviation of that. And then the last category, or base quantity, is the luminous intensity, which is basically light intensity. And what unit do we use for that? A candela. All right, a candela, and we abbreviate that with the letters CD. Now we could use any of these with this metric system, right? It depends on what we're talking about, what we're actually measuring. And so one of the things that you might be familiar with already is the staircase model, right? And this is something that's taught definitely in middle school, frequently, maybe even in elementary school. And if you know the staircase model, that's great, but it's just a starting point. We're going to add some complexity to this. So let's go ahead and label this. I want you to go ahead and sketch this out, but leave space up at the top and leave space at the bottom. And what I'm going to do is start to label this. So let me pick a different color than my staircase here. So what I'm going to write here is kilo at the top, on the top step. And really what we're going to talk a little bit about is how we would go about labeling these prefixes, right? So the base quantities are the end of the word, but the prefix is going to give us a quantity level of it. So we've got kilo, and then we've got hecto, or let's put a little dash here so you know that there's something that comes after that. Then there's hecto. And then we've got deca. And then here we call, what we have is we call a base unit. But it's not quite the same as our quantities that we just listed before. So these base units could be one of 3 things. Or actually multiple things, but these are the standard ones that we often talk about, is grams, liters, and meters. We could talk about candelas, we could talk about amperes, we could talk about the other units as well, right, the Kelvin. But this is where that base unit sits, and then we'll keep going down the stairs here. We'll come back to this base unit in a second. Then we've got deci, centi, and milli. Centi, and milli. Okay? So what we're talking about here is that this is a staircase, because this might help us convert units by the unit 10, right? So I'm going to add another color here. So let's say that we're talking about 1 gram, right? So we're talking about a number 1 here. It's 1 gram. Well, to figure out how many decigrams are in 1 gram, we're going down the staircase 1 step. That means we multiply by 10, or we add 1 0. So there would be 10 decigrams in 1 gram. If we're going from 1 gram to centigrams, we go down 1 step and then a second step, and so we add 2 zeros. There are 100 centigrams in 1 gram. If we go down to milligrams, we're going 1, 2, 3. So there are 3 zeros that are added to milligrams. So there are 1,000 milligrams in 1 gram. We know that to be true for like meters, right? We know that there are 100 centimeters in 1 meter. There are 1,000 millimeters in 1 meter. But if we were to go the other way, how many decagrams are in 1 gram? Well, if we're going up the staircase, we're going to the left 1. So this would actually be 0.1, because in 1, the decimal actually comes after it. So we're moving the decimal place 1 to the left, so there are 0.1 decameters in 1 meter. There are 0.01 hectometers in 1 meter, and I'm going to tell you that I do expect a 0 before the decimal point. Okay? And that's just formatting, and it's for clarity, it's for consistency. And if you're going from 1 gram to kilometers, how many kilometers are there in 1 gram? Well, we're going 1, 2, 3, up. So we're going to move the decimal back 3 places. So 1, 2, 3. It's going to be 0.001 kilometers in 1 meter. So again, it's just moving up and down the scale. But you should also know that this is not the end of the staircase, and this is not the end of the staircase. We could keep multiplying by 10 or dividing by 10. And in fact, we've already done that. So we know that we can actually go beyond millimeters, but I'm going to make these small staircases because we don't typically use these. But this one we sometimes use, and this one we call our micrometers, right, our micro level. And then we can go down, we skip 3 more, 1, 2, or we go down to the third one from that, and we call that level nanometers, right? And then we can go 3 more down, 1, 2, 3, and now we're talking about picometers. So these are really tiny units compared to our base unit, but they're just units, right? There's nothing really scary about them. But if we were to talk about, let's go from 1 millimeter, 1 millimeter, how many micrometers are in 1 millimeter? You might already know this, right? You might already know that 1 millimeter equals 1,000 micrometers because you memorized that. Well, if we're going from 1 millimeter, we're going to go to micrometers. We're going 1, 2, 3 steps to the right. That means we're adding 3 zeros. So that means that this is going to give us 1,000 micrometers is equal to 1 millimeter. And that's one way you can figure this out. I hope that makes sense. But when we're talking about, if you have questions about this, we're going to talk a little bit more about this. I do highly recommend that you have some questions about this so that when you are doing some conversions in class, you know what you're going to be doing. So take a few numbers, right? So let's add a list up here. You might want to then write these down, pause it, and try to work these problems. And if you're unsure about this, talk to your teammates, talk to your friends, talk to me in class. Let's make sure you understand this conceptually. So let's ask how many millimeters are equal to 1 kilometer. Let's ask how many hectometers are equal to 300 centimeters. And let's do one more just for practice. how many liters are equal to 0.5 micrometers. Okay? So see if you can work those three problems, and if you feel confident in what you're doing there, that's a great first step. Okay? So what I'm going to do now is talk a little bit about scientific notation. I'm going to take away this thing. Alright, so scientific notation. So scientific notation is actually quite important for us. So scientific notation allows us to be able to do some very straightforward, simple math because we change the format in which the numbers look. Excuse me. So if I had a number, like you saw in class, one of the things that we're always working with is like kilograms and meters. So when we're talking about kilograms and meters, we often will need to convert our numbers into these things, right? So if I know that, let's say I've got a distance of 5 centimeters, well, we need to be able to convert that into meters. So how many meters is 5 centimeters? So I know that, well, what I know is that this is, from going from centimeters to meters, I'm going up the staircase to the left 2 spaces. So that really is going to be moving 1, 2, back here, put a new decimal place, this one gets canceled out. So I know it's 0.05 meters, right? So that's how many meters is equal to 5 centimeters. So it's not changing anything, right? It's not changing my value, it's just changing the unit. But this is not a good number that we like to use. This does not fit our scientific notation. So scientific notation requires that we use numbers between 1 and 9. So we've got to fit our basic numbers in between that range. So this is less than 1, so I need to change that to something that's between 1 and 9. So if I were to think about this, if I multiply, well, what I can do is say that this is going to be 5 times 10, and I'm moving back 2 spaces, so 10 times -2 meters. So now I'm still in the unit that I want to be for my formulas, which is really key. And now I've got numbers that are a little bit more manageable. I can see 5 and I can see 10 to the -2. And when we talk about exponents, you're going to employ some of your exponent rules, right? So when you're dividing by these numbers or multiplying, you're going to use exponent rules. And if you don't know what these are, you need to come see me or Miss Drew to figure out how do you do this. So if you, for example, if you had 5 times 10 to the -2 meters, and you had to divide that by 6.7, right, so that's between 1 and 9, times 10 to the -4 meters, there's a very easy way to simplify this. But in reality, what these numbers mean, is we're talking about 0.05 meters times 0.00067 meters. So that's a lot messier to actually do, and especially when you're talking about 10 to the -12, 10 to the -18, or 10 times some number times 10 to the 20, it's going to get to a version that you are not going to be able to put into your calculator and find the solution. So you need to have some number sense about how to do this. And you might already know, oh, well, I'm going to cancel out my units, right? So I'm going to cancel out these zeros, 1, 2 zeros, 1, 2, and cancel out these 2 zeros. Now we've got 5 divided by 0.006 point. Yeah, so it's not any easier, right? So there are tricks to these exponent rules, which are going to be really key. I hope that makes sense to you. How do you go from 0.05 meters to 5 times 10 to the negative 2? But that's something that we're also going to work on a little bit, is some scientific notation, so that you can think a little bit more about how to make sure that you end up with a unit that you're looking for. So, for example, when we're talking about kinetic energy, your formula is 1/2 times mv squared, where m is mass in the unit kilograms. So any number that you put in for m needs to be in terms of kilograms. You didn't have to do any conversions in the practice problems because you may not have known how to do that yet. Velocity is always in meters per second, because this is our base quantity for length or distance, and this is our base, seconds is our base quantity for time. So you have to always convert to those units. So this is where you want to go back and review the unit conversion video that I'd gone through, because another way to do this, what I had said to you was this staircase is a good way to start, but a better solution to this is if I'm thinking about, I'm going to take the same problem here. I'm trying to figure out how many meters are equal to 5 centimeters. The strategy that you should really be using is, what do I know about the relationship between these two things? And I know that there are 100 centimeters in 1 meter. That's an equal quantity, it's different units. So if I'm going from 5 centimeters, I had done parentheses in the previous video, but sometimes this is called the railroad setup. So 5 centimeters over 1. In my next quantity, I have 100 centimeters to 1 meter, and I'm trying to get to meters. So that's all I really need. But how do I set that up in this equation? I want to cancel out my units. So if I've got centimeters in my numerator, I need centimeters in my denominator, and I need the target unit in my numerator. So when I divide 5 centimeters by 100 centimeters, my units cancel out, and now I've got 5, so I made this too long, but we could have more steps if you need more conversion factors. We end up with 5 meters over 100, so that's a 20, that's 1/20th, right? So 5 goes into 100 20 times. So this is going to be, so it's 1 over 20 meters, which happens to be 0.5 meters. And another way, the other thing that I think about is, well, how many times, if this is 1/10, the answer would be 0.1. But 1/20th is half of 1/10, so it's going to be half of 0.1, which is 0.05. Right, so I hope that makes sense to you. Or if you write this in scientific notation, if we're going to move that decimal back to get a whole number here, we're going to end, or have one number to the left of the decimal place. We have to move to the right 2 times. So to get from 5 meters back to this number, we have to move the decimal place back 2 spaces. So this is 5 times 10 to the negative 2 meters. And that's how we get to the scientific notation. Okay? And I'm going to stop there because I'm going to make another video for you.